That. So, Ronald, we're going to take some questions that have come from the participants, and any particular question you're going to start off with.
So yes, so some of the questions are very technical, some of them are less technical. So I'll start off with I'll mix the questions up and go from a technical to a non-technical question. So firstly, we've got a question about what is our opinion regarding meshing within an SD-WAN environment. So the architecture that you can use in SD-WAN consists of two types. One is a mesh and one's a hub and spoke. So what that means is in a mesh environment, everybody speaks to everybody. In a hub and spoke, a person that's at a site can only speak to a hub. So there are benefits of hub and spoke, and there would be benefits of a mesh. So a mesh is typically how the internet is constructed, where you've got multiple cities talking to each other. In that environment, you aren't always optimizing the last mile path. So here in SD-WAN, we're talking about the last mile and optimizing the last mile path and making certain that we can fail over on it. So the way we approach it as Fusion Broadband is we use a hub and spoke mechanism to the nearest data center. And from that data center, we allow multiple paths coming back to the edge, which allows you to fail over. And also it allows you to fail over extremely quickly, because that's what we want. We want reliability. In a mesh environment, you do not know what the status is of both sides of the link. So in a mesh environment, you typically take upwards of 30 seconds to fail over between links. Now in 30 seconds, you'll lose your connection, you'll lose your transaction, you might have to start again. And if your transaction has been corrupted, it might take you quite a while to actually recover and get back to where you were. So in the last mile, it's a lot better to use a hub and spoke. However, when you have a large branch network, and let's take an example, you've got branches in Cape Town, Durban, and Johannesburg, and you want them to speak to each other. It doesn't make sense to have a single hub for the whole country. It makes sense to have a hub in Durban, a hub in Cape Town, and a hub in Johannesburg. Now you've got 3 hubs. The best mechanisms to let those hubs speak to each other is with a mesh network. So when you're building the hubs and getting the hubs to speak to each other, you mesh them. What that means is Durban can speak to Cape Town and Johannesburg. Johannesburg can speak to Cape Town and Durban. And so they all mesh to each other. And as you add more and more sites, for example, if you add London, you'd probably add London in a mesh on the hubs. But you wouldn't have a hub and spoke mechanism for all countries and all connections. The next question we have is around the different use of multiple links with different form factors, and how does a SD-WAN cater for something that is asymmetrical in a broadband environment. So for example, broadband, most links that you buy for fiber to the home or fiber to the business is asymmetrical. You'll have 100 megabits per second down and 50 megabits per second up. So what you would do typically often in a normal environment, even if you had a router and 2 routers, you'd only be able to use 1 connection path. So your uplink would be 50 megabits per second in the example where I said you had 100 down and 50 up. If you had multiple lines and you had 2 hundreds down and 2 50s up, you would get 200 down and 100 up. So immediately the bandwidth that you're utilizing is aggregated across the number of links that you have. So you'd still have asymmetric bandwidth, but you'd have the ability to use all of your bandwidth going up and down. So in this scenario, you wouldn't just be able to do 50 up, you'd be able to do 100 up. The next thing is, how does packet loss affect the SD-WAN solution? Well, in many of the cases that we've done, we've actually found that SD-WAN is in a way able to mitigate packet loss problems. Now, packet loss problems aren't just restricted to ADSL wireless. They also happen often on fiber. And what you notice when you have packet loss on a fiber is the immediate thing that gets a connectivity problem is international sites. International sites start slowing down. So in Fusion, we've got the ability to mitigate those packet loss scenarios and still maintain connection to international sites at full line speed. And that we do by actually mitigating the actual problems associated with packet loss. So one of the immediate problems that you have with packet loss is when you use something like TCP, things become out of order. You have to have a large number of retries. So we're able to, with our technology, minimize the number of retries that are required and the number of packets that arrive out of order. And minimizing that, there is a mechanism of being able to mitigate the actual problem with packet loss. Another mechanism that a lot of SD-WAN utilizes is something called forward error correction. The only detrimental aspect of forward error correction, which also does mitigate packet loss, is that you require more bandwidth. So for example, if you had problematic sites, you would be utilizing more bandwidth, not less bandwidth. Sometimes it might mitigate the problems. Often you might exacerbate the problem because you're putting more bandwidth to a solution that doesn't necessarily solve itself always with more bandwidth.
So Ronald, if I can ask the one question that's in my mind is how does SD-WAN, if you've bought a particular link at a particular bandwidth, how does it accelerate to the cloud? Because obviously it says you've bought a certain capacity. Acceleration to the cloud, is it linked to
firstly, the obvious one is the aggregated bandwidth. So for example, if you've got 20 megabits per second fiber and 20 megabits per second wireless, you can use now 40, and that's immediate benefit. The other method that a person utilizes is there's a mechanism of very well known called TCP acceleration. For example, have you ever heard of people complain about their YouTube quality?
No.
The reason for that is because Google has rewritten YouTube to use a specific algorithm called BBR, which is an algorithm that when packet loss occurs, it doesn't actually pay attention to the packet loss that has occurred, because with video that is being transmitted to a person, you want it to be there as consistently available as possible and not to stop and, what typically would be called buffering. So YouTube has got that nailed down because it's got this algorithm called BBR, which allows you to actually do that and mitigate that. So those types of mechanisms are available in SD-WAN. There are probably right now about 14 congestion control algorithms available. And depending upon the situation, one congestion control algorithm will work better than others. Then the final way of actually improving cloud acceleration is to actually have multiple TCP sessions, not just one. For example, if you have a storage solution like Dropbox and you synchronize your laptop to it and it takes 50 minutes, if you connect multiple TCP streams to that instead of one, and you, for example, do 8 to 12, you can immediately improve the speed on which you synchronize your hard drive to comparably 8 times. And I've typically done that often on my laptop, and it's quite impressive that the synchronization gets speeded up so fast.
Thanks.
Okay, the next question we have is about the actual centralized internet breakout. So SD-WAN, you can have centralized breakout or you can have localized breakout. And in essence, you're talking about what is the benefit of centralized breakout versus non-centralized breakout. Well, in South Africa, it is actually a moot point, because in South Africa, all our internet goes through very limited data centers. Even if we do an internet breakout in our office where we are here right now, we would follow the exact same path physically that we would if we did a centralized breakout. So in South Africa, given the physical constraints and the limited number of data centers we have, there is actually no difference between centralized and decentralized internet breakout. It's effectively the same. It's effectively the same thing. So why would you actually want to do centralized breakout instead of decentralized breakout? Well, if you're an organization with 60 branches and you do 60 localized breakout points, you've just got 60 points more to manage. Yes, you can say your automated software is going to make that better, but you still got the probability now of having that internet breakout as a probability where you have to deal with 60 breakout points where you can have one. It comes down to the thing with, would you rather look after one entry and exit point than 60? It's going to be a lot simpler and more reliable to look after minimized entry points in and out of the network.
But that also has a security benefit.
Correct.
Because then you're essentially managing one access point, one gateway into the rest of the network.
Correct. I mean, it reduces the probability of you having a backdoor into your organization, which you don't necessarily want. The other thing about it is that when you are doing things like having firewall functionality in a decentralized manner, in a small office, you're not going to get a high-powered firewall. You're actually going to get a low-powered firewall. You're going to get something that's cheaper because you're not going to buy something that's expensive for that office. So you're going to get a cheaper firewall. A cheaper firewall means less functionality, less performance, less ability to provide reliable security. If you have a centralized breakout where you take all of your offices and you consolidate it into a data center, that allows you the ability to actually buy a high-end firewall and spend more money on it. Spending more money on a high-end firewall will ensure that the hardware is better. It can take performance better. It can take security breaches better. It can take denial of service attacks better and mitigate them in a better fashion. It can execute the rule-based better. So you get all of the benefits of you getting a better device and being able to afford a better device by aggregating all of your costs and putting them into a singular cost instead of spreading them out all over the place and reducing the quality of what you get at a single site because you have to cover multiple sites with a cheaper bit of hardware. Okay, the next question that we have is around how many forms of connectivity can the SD-WAN handle at a site? So in South Africa, we have got a maximum of 3 types of connectivity at a site. But over in Australia, there is a site that can handle up to 12 different types of connectivity. In reality, you're constrained not by the SD-WAN itself, but by the ability to actually get physical connectivity and different types of connectivity into a site. For example, we struggled in our office park to get more than one fiber connection. The office park has only had one fiber trenched into it, so we're totally reliant upon that. We can get multiple wirelesses, but after that, we're not going to get anything more. So in SD-WAN will handle as many types of connections that you throw at it. The problem is going to be, is at that location, are you going to be able to get that many types of connection to that particular site?
So just with that point, Ronald, we've tested on using satellite, for example, in the very beginning.
Yes.
So that's another form of connectivity in terms of areas that are not covered by either technology. And in order to get greater bandwidth, for example, out of satellite, if you fused 2 or 3 satellite connections together, you would then get greater bandwidth in, for example, a rural area.
Correct. So and at this moment in time, satellite is still an expensive option, but it is a very reliable option. The uptime on satellite is very good. But typically, satellite connections have larger latency and they're slower. There is definitely more of those connections that are going to come in once Starlink becomes widely available and they've sorted out their deployment issues and it becomes available, because there it's going to be reasonably good bandwidth of at least 20 megabits per second with better latency. So you would be able to actually utilize that in a remote location when there is nothing else available, or as a means of backing something that you've already got.
Yeah, so the SD-WAN is ready for that development.
Correct. So next question here is, how important is it to consider the underlying design when building an SD-WAN solution? So it all depends upon the market segment that a person is playing in. For an example, in an enterprise market, when you're working with a big bank or a big retail organization, it's extremely important to look at the underlying design because of the complexities in their IT system. They've got extremely complex IT systems, and you're going to have to design and look at the design specifically for an enterprise. And typically, as soon as you start doing that, there's costs involved, and the SD-WAN solution for that enterprise is typically going to be proportionately larger. In the small business environment, you've got a lot more consistent in the way that businesses handle their communication requirements. One small business's communication requirement isn't going to be that much different in the small business environment than another business. In the enterprise market, you'll never find two enterprises with the same communications and requirements. So there it becomes less of an issue in the small business environment. There, what you want is something to deliver consistently and as fast as possible. In an enterprise market, you're typically not going to be able to deliver something unless the enterprise changes its behavior and way of doing business, that it is actually a cookie cutter business, that it actually does things in a rapid manner, in a consistent manner, then it will probably fit well into the enterprise market. And the actual design of an enterprise solution that's specific to the enterprise will become less important. But at this moment in time, enterprises are very customized in how they've done things, and they will probably remain like that for a while. The benefit of the cloud solution is that when you get to the cloud, you're forced to do things in a standardized manner, and you're forced to provision and do things in a more structured manner. So as enterprises move more and more to the cloud, the ability to force a standardized mechanism that is easier to deploy for enterprises will become more probable and more likely that they'll be able to do that.
Yeah, but Ronald, one of the things that exists in South Africa still is a lot of companies still have servers on premises.
Correct.
A big percentage of small, I mean, we're talking enterprises, fairly large companies have servers on-prem, and that's one of the things we didn't really spot, where customers were requesting a failover and reliability and multiple links into the business rather than going out of the business, essentially to provide reliability of all those remote workers remoting into servers that are on premises.
Yes, for example, the on-prem business has been largely underestimated because a lot of people said the natural migration is to go into the cloud. But the cloud doesn't necessarily always fit everybody's pocket, because if they've spent something on-prem, going to cloud is an additional expense, no matter how you look at it. The other aspect of a cloud migration is that there are typically project costs associated to it. And the costs of cloud are on demand. If your business is consistently the same and doesn't change day by day, eventually, when you do the maths, it's going to pay you to keep on-prem and do things with your own hardware than it is to use cloud hardware where the costs are larger. However, if your business is such that it fluctuates greatly from day to day, from month to month, from season to season, there's no way that you can keep on that type of scale with on-prem solutions where suddenly you need to go and buy 100 new servers. You can never do that. Then there you're forced to go to cloud. Okay. So there is the thing, and a lot of businesses have on-prem servers and they actually don't need to move yet.
Okay.
The next question we have is, in your opinion, why does SD-WAN make applications perform better, faster, excluding acceleration if built into the solution? So the mechanisms that SD-WAN utilizes is when you have a system that is able to do failure within a couple of milliseconds as opposed to 30 seconds, it makes it more reliable because you don't have to restart your transaction. The other question is, when you have acceleration built into it, and that's one of the benefits of SD-WAN, is you can often purchase solutions that do accelerate your traffic type as an additional service that can be integrated into SD-WAN. But that is very specific to the type of application you're using and the business requirements for it. So it's not a generic thing that all applications can be accelerated, but definitely there are those that can be accelerated, and there are those that can be accelerated with third-party solution add-ons that can be integrated into SD-WAN. What additional security features does Fusion Broadband have in addition to firewall capability, something like DNS? So at Fusion Broadband, we've actually developed a rock-solid DNS. And the way we do our DNS is we utilize multiple upstream DNS providers. One of the big things that is overlooked and how people don't understand around DNS is there are DNS services that provide you a great security benefit just by utilizing them. An example is Quad9, which is actually sponsored by IBM. What Quad9 does as a DNS is, if you're using Quad9 and as a business you're using it, it immediately blocks your laptop or anything on that site from getting to a command and control server where people can actually put malware and control malware on your laptop. It blocks all of that access immediately. So it immediately makes your network secure just by doing that. The second thing that you can actually do, which is the proactive blocking of websites. So for example, somewhere in the world right now, there is somebody who is trying to hack somebody. The addresses that those are coming from are known within a couple of minutes. So there are organizations like IBM and other organizations that do publish that knowledge to you, which is called threat intelligence. You can take that threat intelligence and apply it immediately to your site and say, we know that there is, for example, a server hosted in a cloud location in Los Angeles, America, that is a command and control center for malware. Just block access to it. And immediately anybody from your site who is going to go there is going to be blocked, and it's going to stop that type of malware from spreading. We are actually, we've got a couple of other questions, but we would, we've got one or two questions still that has come from the audience, but what we will do is we'll answer those directly and send them to the guys who've answered the questions.
Yeah. Well, thank you for all those questions. Hopefully this has been an informative session. We've got a lot more questions, and I think what we're going to do is, Ronald, we will answer them, definitely. And anybody else who's got questions, we can be reached. Send us an email on sales@fusionbroadband.co.za. That email again, sales@fusionbroadband.co.za. And we'll gladly answer any question and queries, and especially if you want any more information. I think we want to share the knowledge and try. And Ronald's goal is to promote SD-WAN adoption in South Africa. Well, thank you for joining us.